In this video, I'd like to talk about simplifying square root expressions, but with variables. So you can see this example here, and I'm just going to rewrite it. So you have 3 times the square root of 5a times 8 times the square root of 35a squared. Now, the general strategy, or at least how I approach these, is to essentially combine all the numbers on the outside and to combine all the square roots into one expression. Since we know that if, let's say, we have the square root of 3 times by the square root of 5, that we can combine these into one expression, the square root of 3 times 5. So if you have a product on the inside of your square root, you can break it up into a product of square roots, or vice versa. So you can go either direction. And to simplify these square roots, it's usually easier to just combine them all into one square root first and then try and simplify from there. Sometimes there are other methods that make more sense, but that's the general strategy which you can use. So we're going to combine the outside terms first. I'll do that in white. So 3 times 8 makes 24. And then we want to combine the inside terms. So we still have the square root, but we have 5a times 35a squared. So we at least know we have an a cubed, and 5 times 30 would be 150. 5 times 5 is 25. 150 and 25 make 175. And so from here, we need to see if we can simplify the square root of 175 and the square root of a cubed. So what I'm going to do next is separate my number and my variable terms. So we have 24 and then the square root of 175 times by the square root of a cubed. So we can deal with the numbers and the variable expressions a little bit separately. So let me make some room first so that we can do this. And for the numbers, I would recommend making a tree. So we have the number 175, and we want to ask what two numbers multiply to give us 175. And so we can do 25 and 7. And then 25 is just 5 and 5. So 175 is 5 squared times 7, since all the branches are 5, 5, and 7. And since we have a square, we're going to be able to take the 5 out of the square root. But we'll come back to that in a moment. And then for the variable expression, you want to separate this into its perfect squares. So square root of a cubed, if we separate it into a squared times a, because now we can break it up into two square roots multiplied together, root a squared times root a. And the square root of a squared, they cancel each other out. The square root and the square cancel, and you just get a. Since remember, square roots and squares are opposite operations. So whenever you have the square root of x squared, you can just simplify this to x. And technically, you have to be a little bit careful because this is really the absolute value of x. But we're assuming that our variable is positive, so we don't have to put those absolute value bars. So we can just leave it like that. And again, we'll just say if x is bigger than or equal to 0. If it's negative, you have to put the absolute value bars. And that essentially just says that no matter what number you start with in here, if it's negative or positive, when you square it, it becomes positive, and then when you square root it, you get back the positive square root of that. So even if it is negative, you're still going to get a positive answer out of here, and that's why you have to put in the absolute value bars. Because, like I said, if you started with negative 3, you square it, you get positive 9, and then the square root of that would be positive 3. So you would actually get the opposite back of the original x value you started with, but if you put the absolute value bars, the absolute value of negative 3 is positive 3. So going back to our problem here, we can just simplify this to a, since a is positive, times root a. So that's this expression here, and then the root 175, let's work on that as well. So I'll just rewrite it. We get 24 times 5 squared times 7. So I'll write 5 squared times 7, or actually I'm going to put that in a separate square root, root 7, because this right here, square root of 5 squared, would just simplify to 5. It's the same as this scenario here. Since if we square it, we get 25, and then the square root of 25 is 5. And then over here, we already knew what we did with our variables. This root a cubed just became a times root a. And now we can simplify the 5 squared term. So this becomes 24 times 5. And then I'll bring the a in front since it's on the outside. So all the numbers on the outside of the square root come to the front. And then we'll recombine the 2 square root terms since we can't simplify those. So we have root 7a. And this right here is the correct answer, though we can't actually carry out this multiplication. 5 times 20 is 100. 5 times 4 is 20. So you do get 120a and then square root of 7a. So that's what you'd put in the box. 120a times the square root of 7a. So the general strategy, combine the outside numbers, combine the inside numbers in one square root, and then deal with the numerical portion of the square root and the variable portion separately. And the best way to get practice with these is to simply just do a whole bunch of them. So let's keep moving on and solving more of these. So again, we're going to simplify here. Now, nothing's on the outside, so we're just going to combine all of these square root terms into one. So essentially, we just have the square root of 3x to the 4th times 5x squared times by 10. Since we have a product of square roots, I changed it to the square root of a product. So now they're all multiplying together on the inside. And let's simplify or just combine everything together, actually carry out this multiplication. So we get 3 times 5 times 10. So I'm dealing with the numbers first, and then I'll deal with the letters second. So I deal with them separately since they're not necessarily related at this stage. So 3 times 5 is 15 times 10 gives us 150. And then x to the 4th times x squared would be x to the 6th. So with the numbers, remember, you want to make a tree. So we have this 150, and that's just 25 times 6. And so that is 5 and 5, and this is 3 and 2. So 150 is really 5 squared times 3 times 2. And then x to the 6th, deal with that over here. So root x to the 6th. I'm going to rewrite it as a bunch of perfect squares multiplied together. So x squared times x squared times x squared. Or you can rewrite it as x squared and then cubed. So either way works, but basically once you write it like this, we can break it up into separate square roots. So this becomes root x squared times root x squared times root x squared. And each of these is just x, since we know that the square root of x squared is the absolute value of x, but we're assuming x is positive. So we can drop the absolute value bars, and you just get x times x times x, which is x cubed. So this simplifies nicely because this is an even number. In fact, anytime your exponent is an even number, all of the x's are actually going to come out. Or I should say half of them. So like if you had the square root, let's say, of x to the 22nd, half of those x's will come out on the on the outside. This will just be x to the 11th, but you would essentially just do this process. This would just be x squared, but you have it 11 times. So when you square root it, the square goes away and you just get x to the 11th. Just like here, the square goes away and you get x to the 3rd. So that's the general pattern when they're even. Now, when they're odd and you're taking a square root, you're always going to be left with one variable left on the inside, and then half of the remaining ones come out. So let's go back to our problem here and start plugging things in. We'll carry on right here. So the square root 150 times x to the 6th. Well, we knew that the square root of 150, we're going to be able to break down into this product here. And the square root of x to the 6th, we'll actually be able to simplify that and just get x cubed on the outside. So this term effectively goes away and just becomes x cubed. And then we have the square root of 150, which is 5 squared times 3 times 2. And I'm going to break it up into x cubed times the square root of 5 squared times by square root of 3 times 2, which is just 6. So I'm going to rewrite it as root 6. Because 3 and 2 do not have any squares with them. So they're not going to be able to come up to the outside. So this 6 is going to end up staying on the inside by the end of the problem. And the square root of 5 squared is just 5. So when we take this square root, we just get 5x to the 3rd and then times root 6. So the root 6 is the only thing that has to be left on the outside. Everything else was able to come out.